All right, so this is going to be finding the LCM. LCM stands for what? Least common multiple. Using prime factorization. So we're going to be finding the least common multiple of numbers. We'll be finding the least common multiple of monomials as well. Okay? So we're going to start off kind of easy. And we're going to use the numbers 10 and 15. Okay? Now, before using finding the LCM just the normal way, you'd list out the multiples like 10, 20, 30, 40, 50. And you would find a multiple that they have in common, which would be 30, okay? So most of us could probably find the LCM of these two numbers just mentally, but I wanted to start off with an easier example, okay? Just like what we were doing the other day when I was saying writing the prime factorization, if you feel more comfortable doing the factor trees for each of the numbers, then fine. But if you're okay with just writing it out, then that's good too. So for 10, I know I can divide it by 2. So then that would leave me with 5. So 2 times 5 would be the prime factorization. 15, I can divide it by 3. And that would be 3 times 5. So the difference here with the GCF, we are going to still identify things that they have in common. So in common, they only have this 5. So if I was finding the GCF would be 5, okay? But the LCM, no. We are going to take all of the prime numbers, okay? We're going to multiply all the prime numbers together that we have, but we're only going to multiply the numbers that they have in common once. Meaning, I'm going to highlight up here. I'm going to take this 2 and the 3, and I'm only going to take one of these 5s. So 2 times 3 times 5, which is 30. So it kind of helps that we already knew what the answer was to this one, because it then reinforces that we're on the right track. So once again, you write the prime factorization, identify what they have in common, just like we did the other day, but then you're taking all of the prime numbers and you're multiplying them all together. The things that they have in common, you're only counting one time, okay? Any questions about this one before we start doing, because I'm gonna get a little bit harder on each one. Okay. So for the next one, I am going to give you 3 numbers, okay? Oh, I take that back. I'm gonna do 2 numbers, 15 and 80. Now, we already wrote the prime factorization of 15 in the last problem. What was it? 3 times 5. So now we need to write the prime factorization of 80. Again, you can use a factor tree or you can just do it mentally. I know I can divide by 2. That would be 2 times 40. And 40 I can do 2 times 20. And 20 I can do 2 times 10. And 10 I can do 2 times 5. What do these 2 numbers have in common?
5.
A 5. The only thing they have in common is a 5. So again, when I find my LCM, I'm going to multiply all of the prime numbers together. 2, 2, 2, 2, 3, and a 5. Okay. I'm only using one 5 though. 2 times 2 times 2, 3 times 5. If you have a calculator, probably now would be a good time to get it out. And if you don't have a calculator, you can kind of rely on those people that do have a calculator. Once you do your assignment, you can just use a calculator on your Chromebook. That would be fine. But for those of you that have a handheld calculator, that's going to be easier for you right now. I mean, you're welcome. You're totally welcome to do that multiplying, work it out yourself without a calculator, but why? 240. That's right. So you can see that this method would be a lot easier to use to find the LCM, because can you imagine listing out the multiples of 15 all the way to 240? 15, 30, 45, 60. That would take a long time, wouldn't it? Okay, that would take a long time. It would be a lot of work. So if you have one that's easy, like this first problem, fine, use the normal way. But if you have these harder ones, then using the prime factorization actually is the faster way. Okay. All right, I'm going to give you one to do. I would like for you to find the LCM of 45 and 150. So if you're done doing your prime factorization, you might want to check with my prime factorization up here to make sure you have the right prime numbers.
Oh, I got the top one differently. I did it with 2.
Well, you can't use 2 for 45.
Oh, I did the wrong number. I didn't.
Well, that would make a difference, wouldn't it? It doesn't matter if you list your prime numbers from least to greatest. The only thing, it might make it easier for you to match things up, but it's not gonna. Right here, is that what you mean? Or down here?
Down there.
Oh yeah, it doesn't matter down here. I personally like to list the things that they have in common, and then I list the things they don't have in common, or vice versa. That's up to you. Okay, so be careful when you're matching things up. They both have a 3 and they both have a 5. Notice my highlighting up here. If that's something that could help you, maybe you have a highlighter and you could do the same thing if it helps you. So it doesn't, it was a really good question I got here. Does it matter when you write your numbers down here if they're in order from least to greatest? No, not at all, okay? So do in whatever way is the easiest for you. I'm gonna need 5 numbers though. You can kind of see that with my purple highlighting. So I'm gonna write down the ones that they don't have in common, the 2, the 3, and the 5, and then I'm gonna write the ones that they do have in common, which are the 3 and a 5, okay? And I know on my paper I even kind of did that, and that kind of let me know, hey, those are the ones that they shared. Whatever works for you, okay? So then use that calculator, and what is your your LCM? 450. 450. Okay, this will also work if you have more than just 2 numbers that you need to find the LCM of. So we're going to do one of those, and then we'll move on to monomials. So we're going to use the numbers 15. We'll use that 15 again. 35 and 70. So let's go ahead and let's do this one kind of together, because there is something that I want to point out about it that's a little bit different than the others. 15, hopefully we all know by now, is 3 times 5. What would 35 be?
7.
All right, I'm going to do 5 times 7. Now again, you're not going to get these wrong if you don't have them in numerical order, okay, because this is kind of like your work. But it will probably be easier for you to match things up if they are in numerical order. All right, and then 70, that would be 2 times 35, so, and 35 is 5 times 7. All right, what is something that all of them have in common?
5.
They all have a 5. Okay, now, do you notice that only 2 of them have a 7?
Mm-hmm.
Okay, we're still going to circle them. So even if all 3 of the numbers don't have it in common, as long as at least 2 of them have it in common, we're going to circle it. All right, so that's gonna be kind of a thing something that's a little bit different. So this has this 3 by itself, this one has a 2 by itself, and then we have a 5 and a 7. It is 210, yeah. So again, they don't all 3 have to have a common factor in order to circle it. So if there's 2 of them that have it, you would still circle it. Okay? Ready for monomials? Okay, so the monomial part does not make it any more difficult whatsoever. Our first monomial will be 20xy squared. And our other monomial will be 25xy cubed. So remember your coefficient, the 20 and the 25, you just do your normal prime factorization for those. So 20 is 2 times 2 times 5. And then 1x and 2 y's. $25 would be 5 times 5, 1x, and 3 y's. For those of you that have not very good handwriting, can't change that, right? Can't change that. My advice to you is I would try to slow down in your writing and write maybe bigger. That might help you, because people that have bad handwriting struggle with this sometimes because they have a hard time matching things up. All right, so number-wise, they both have a 5, correct? Okay. And then they both have an x. And how many y's do they have in common?
2.
2 y's. Okay. So I'm going to focus on my numbers first. 2, a 2, a 5, and this 5 that they share. So 2 times 2 times 5, and the 5 that they share. What coefficient would that be? 100, okay. And then let's focus on our exponents. I'm going to use a different color highlighter here. We have an x, we have a y, we have a y, and we have this y by itself. So again, we have an x, we have a y, we have a y, we have a y by itself. So these things were shared and then that y by itself. So it's going to be 100 x y to the 3rd power. Was everyone okay when you put the answers in Google Form using that up arrow?
Yeah.
Great. It doesn't look good, I know. It doesn't look good. Okay, we okay on that?
Yeah.
Great. Let's make it a little bit harder then. Yay!
Wonderful.
All right, how about 12 x to the 5th, y to the 3rd,
Oh no.
and 16 y to the 2nd, z to the 4th. That's a lot of writing. So yes, my z's look a little weird. That's because I don't want them to look like 2's. It doesn't really matter when you're doing like x times x times x. If you don't want to put the little dots in between all your x's, that's fine. Just don't smush them all together. Oops. We'll only have one more to do after this. Okay. and then a back. All right. So again, I usually just focus on my numbers first, and then I worry about my variables. So as far as the numbers go, they both have 2 2s. So I have this 2 that they share, this 2 that they share, and then we have the 3 by itself, a 2 by itself, and a 2 by itself. And then let's look at variables that they share. Do they share any x's?
No.
No. How many y's are shared?
2.
2. Do they share any z's?
No.
Okay. So we have 1, 2, 3, 4, 5 x's. So I would just write x to the 5th. I wouldn't write x all again, okay? They have 1, 2 y's shared, and then this other y. Okay, so how many y's total? 3. And then no z's are shared, so we're going to count these 1, 2, 3, 4. What is my coefficient here, by the way?
48.
I agree. 48, x to the 5th, y to the 3rd, z to the 4th. Now, if you thought that the other answers were ugly with those carrots, this one would be really, really ugly. You don't want to put any spaces in between things. You don't have to write this in your notes, but it's going to be super ugly, okay? So just take your time. So you have your 48, you have your x to the 5th, you have your y to the 3rd, you have your z to the 4th, okay? Don't put spaces in between things though, and you'll be fine. It does look better when it's typed at least. It still doesn't look great. Okay, one more, and then we'll be finished with our notes today. I'm going to let you try this one on your own, okay? Okay. 24, x to the 5th, y to the 4th, and 42, x to the 3rd, y to the 6th. The alarm will probably go off on my phone. I don't know if it'll go off while video.
It's already going.
Oh, is it? Okay. Oh well.
Oh my goodness.
You do only have 10 of these today, by the way, on your assignment. So we have an hour left of school. You'll have plenty of time. I know it's a lot of writing. Alright, so for your coefficient, you should have had a 2 and a 3 that they had in common, and then a 2, 2, and 7 that they didn't have in common. So did anyone multiply that together and get what the coefficient is for this? 168, very good. Alright, and then as far as your your variables are concerned, they have 3 x's in common and 2 that are by itself. So how many total x's is that? 5. And then for your y's, they have 4 y's in common and 2 by themselves, so that's a total of 6. And you're finished. Good? Ready?
Why does it look like you're just multiplying everything together? Like, that's what it kind of looks like.
Well, that's what prime factorization is.
That looks like
You're multiplying those factors together to get this monomial. It's kind of like writing a number in expanded form. You remember doing that in elementary school, writing a number in expanded form?
Exactly.
Also what?
Like exponents and stuff.
Yes.
What would 0 to the power of 0 be?
You know what? We're going to get into the rules of exponents like that, like what something to the power of 0, or something when the exponent is negative. What do you do when the exponent is negative? We're actually going to be getting into that.
Because 0 to the power of 0 is kind of impossible. Because would it be 1 or would it be 0?
Well, we'll talk about it.